in this lecture we are going to talk about constant off time mixed signal current mode control. So, this is this lecture is somewhat similar to our previous lecture where we have considered constant on time mixed signal current mode control. Here we are talking about constant off time. The only difference here is the modulator, that means your constant on time is replaced by constant off time, as well as the sampling age, that means the point of sampling is different. Otherwise, it uses the event based sampling, and the fundamental architecture point of view many things are common. And we will also consider few simulation case studies. So, if you talk about mixed signal current mode control constant off time control, which is analogous to peak current mode control, and we know that if we take any peak current mode control here, so in this particular case the current will rise and then fall like this. So, here our off time is fixed. So, off time is fixed. So, that is why it is analogous to peak current mode control. The only difference here, it is a variable time control where the off time is constant, but the time period can vary. So, this block is using the same, only we are replacing the monoshot timer. Now, this will act like a for constant on off time module, constant off time block, and this is a minimum on time. It is written already, so it is a minimum on time block. Okay. So, this block is the minimum on time. Then the same we need an A to D converter which should be sampled using an event clock. So, here event again is a comparator. So, what is the event? Here the event is, this is the event, that means whenever the inductor current hit the peak current, that is the event. But in practical circuit, even if it hit inductor current will hit the peak current, we may turn off little later because there will be some delay due to the comparator driver. So, we can capture the sample at this point, so that we can capture the clean inductor current or clean output voltage, because we want to avoid, we should not sample at the point of switching as well as just immediately after switching, because that will be noisy data. Because of the delay, actually you can capture the clean sample. Okay. So, you can see this is the age. So, this will be the clock, event clock, which will be used even for computing this controller as well as sampling, because we are not considering additional delay, just to initially to introduce the concept. And this event clock is generated from this comparator, which is shown here. Okay. Here again it is an event triggered ADC we have discussed. Then power stage we can easily develop, we have discussed in the MATLAB. We can just drag and drop that block. Then we can put an adder block, that is a subtractor. Then after that it will go to the compensator. Since we are talking about PI controller, current mode control, we will consider PI controller, and this PI controller will be realized using an event clock. So, this exact representation we have already discussed, and if you go to the Simulink diagram here, if we go inside this block, so this is a PI controller, and we have discussed this block exactly same as constant on time as well as fixed frequency control, only the clock age is different. Here we are using a different clock, and here we are using non-uniform sampling or event based sampling. So, it is different from the uniform sampling. Next, that means we can realize PI controller using difference equation and using a clock triggered operation. Then once we implement this, then output of the controller will generate the peak current, and then we can give a D to A converter. But in MATLAB we do not need a separate D to A converter, but in actual circuit the output of the controller will be digital, and that will pass through a D to A converter, and that output of the D to A converter is the peak reference current, and that will be compared with the actual sense inductor current, and that is the comparator, and that is in the analog domain that we have discussed. Whenever it hit the peak current, that means whenever the inductor current hit the peak current, that means if you draw the peak current reference, and that is the point we are taking this event. So, this event is passed through this, it is generated. Okay. and that means we have this event is created from this comparator output when it just triggered, and this rising trigger actually will generate the enable the monoshot timer, because you have to turn on the constant off time block. When the inductor current hit the peak current, then your monoshot timer is enabled, and as long as the monoshot timer is enabled, the switch will remain off, and that is the monoshot timer. And you can see when it is enabled, it is a NOT gate, so it will be off. And this operation also require a minimum on time, that we know, because all commercial product will have minimum off time for constant off time control, on time, minimum on time for constant off time control. So here this is the minimum on time, and this thing we have discussed in our previous NPTEL course, that is the control and tuning method in switch mode power converter, and I think we have discussed in lecture number 23, the constant of time, 22 lecture we have discussed regarding constant of time. In fact, we have discussed the 23 also, we have discussed 23 as well, where we have compared various things. So, this is in our past lecture of control and tuning method in switch mode power converter. So, all these blocks are common. This block is common for analog control as well as this mixed signal control, but this block is different. That means this block is different, including this DAC. Remaining this analog comparator, everything else is common. So, here as I said, this is common, and I will go to the MATLAB simulating block, and we have to incorporate the minimum time. Then we will go for custom, the complete MATLAB model. This will be the event trigger ADC, error voltage, then controller, event trigger control compensator using difference equation, minimum on time, and then this is the constant off time modulator. And this is the complete block diagram. We are going to MATLAB. So, this is the power stage that we know, and this is the controller. Then if you go inside the controller here, if you emphasize, what will get? This is your event trigger ADC, and this is your controller, PI controller, and this block is a constant off time modulator. And if you go inside the constant off time modulator, then you will see this block. So, this block, it takes IREF and IL. So, whenever inductor current hit the peak current, the rising edge come, and that will trigger the monoshot timer. And this is the additional block which is used to minimum on time, because it requires a minimum on time. And if you explore this block we have discussed multiple times. The only difference, the trigger pulse is different here. That means we are using this trigger pulse, and this is created from the comparator output. So, if we go to MATLAB, so let us go to the MATLAB. So, this is the complete representation of this circuit, buck converter, whatever we have discussed, and the trigger pulse is generated from here. That means if you go to this monoshot timer, the comparator output, you can see the whenever the inductor current hit the peak current, that is the edge is detected, and that is the trigger pulse, and that trigger pulse we are using. This is the trigger pulse, and that is going to the go to block, and this trigger pulse is used for the controller computation. This trigger pulse is used, as well as this is used for ADC. Okay. So, if you go further up, now we are running a case study. So, we want to show a first reference transient response. So, let us say we are using a reference transient response, and let us run a simulation case study. So, now this shows the reference transient case study. So, if you see that the output voltage is changing from 1 volt to 1.05 volt. Interestingly, you will find, since we are sampling here, that means we are sampling whenever the inductor current hit the peak current, that means we are almost sampling at the peak voltage. So, that is why your peak voltage is regulated at 1 volt, but not the average voltage. So, in order to solve this regulation problem, we may have to shift the clock edge little bit. That means, if we take, let us say, if we sample somewhere in between. That means, because during this time your switch will remain off, and when the switch is remain off, that means your monoshot timer is enabled. So you can take the midway point as a event clock. That means we can sample at the middle of the off time. Okay, may not be just beginning of the off time, because if you sample at the beginning of off time, there may be a voltage regulation issue. So that can be addressed. But here I am not showing all this because this can be an advanced study, but you can actually get the reference transient response from here. Similarly, we want to run a load transient case study. Now we want to go for a 20 ampere load step, and reference voltage is now changed, and let us run a simulation case study. So now this shows the load step up transient case study. So here if you go to the inductor current is changing from, initially it was 1 ampere average current, now it is changing to 21. So 20 ampere load step size. Okay. So this is the output voltage response. It is actually a sluggish response, but we have not discussed about the compensator design. So what I am saying here we have considered T by 100 as the minimum on time, but you can customize it. Okay, so you can customize the other parameters. So by that way we can implement the constant off time modulator, and we have discussed the overall diagram simulation, how to implement in Simulink. That means we have discussed the complete block diagram realization using MATLAB Simulink. So in summary, we have discussed custom MATLAB model development for constant off time mixed signal current mode control, and we have also discussed some MATLAB simulation case study. So in the next lecture we are going to talk about digital hysteresis current control technique. That's it for today. Thank you very much.